Welcome to my talk, The Extendables. So as a flavor of what we're going to go through in this talk, we've got a few things. We've got where this research came from, what we can do with it, does anything already exist that sort of takes advantage of this already, what new stuff did we find we could do, are the blue team aware, how can we protect ourselves, and is there an easy way that you guys can test this? So I've already kind of been introduced, but I'm Finn. I'm a security consultant at WhiskerSpy, and I've been for about three and a half years now. My day job mainly consists of finding vulnerabilities in things like applications, networks, to make sure clients' security posture can be good. But as was mentioned, I also look at malware to reverse that and help our defensive teams, and also get the techniques out so we can use them on stuff like red teams. Anyway, that's enough about me. Where did this research come from? So a client basically came to us, and they had this browser extension that they wanted to install in their environment. And they couldn't get a hold of the developer and didn't really know, apart from what it said in the description, what its capabilities were. So they didn't know if it was safe to install on their endpoints. So that was our job. We were tasked to find out if it was safe to install and use. So like any time I'm looking at something that's potentially malicious, one of the first things I do is I install it or load it up in a lab and then sort of just observe what it does first just to see, what's going on. So that's exactly what I did here. We had an MSI file to install this extension and the other bits that it required. And as soon as I loaded it up in the lab, I saw this. Now, the top bit is kind of normal, right? Chrome spawns its Chrome sub-processes as you'd expect. But then we can see there's cmd with some weird-looking command line with named pipes and all sorts going on in there, and then it spawns some rando executable that I'd never seen before, which immediately sort of raised alarm bells in my head. I was like, what's going on here? This is not right? Why is Chrome spawning the cmd and then the random.exe with all those arguments? What are the named pipes doing? What's that about? And it just made me think, this can't be legitimate. This has to be dodgy. So obviously, I got to analyzing it further. So I continued to have a look around the extension itself and the files associated with it, the manifest, the JavaScript, and I kept seeing something called native messaging, which I'd never heard of before. And also, if you remember in the command line from the previous slide, there was native messaging sort of mentioned in there. And it sort of made me think, what is native messaging? And the way it's sort of put in the manifest and the JavaScript, and also in the command line, you can see it's chrome.nativemessaging. It made me think, maybe this is a feature of Chrome, right? So the next logical step for me would be to look in the documentation for Chrome and see if it's mentioned anywhere. And that's exactly what I did. And I found this. So it says that extensions and apps can exchange messages with native applications using an API. Chrome will start the host in a separate process and communicate using standard input and output streams, right? So essentially, it's useful for if we have an executable over here and the browser over here, and we need to sort of do some inter-process communications. As an example, you could think maybe you have an executable password manager, and you have your browser, and maybe you want some functionality of when you visit a certain page, it autofills your credentials. Now, without native messaging or anything similar, there's no way it will be able to get the credentials from one process into the browser process and continue. However, native messaging means that we can have an extension installed on the browser that will just look at all the pages we visit and send them potentially to the password manager. It can then see, has it got any entries for that website for credentials? If it has, great. It can then send those credentials back to the browser where the extension can also fill them. And there you go. That works. That's just one example, but it's kind of a nice one. So what does this actually look like in practice? Well, as you probably remember from the process listing, the browser will spawn a cmd instance, which will then spawn an executable. And then we have those named pipes. One of those is to send information from the browser extension to the native messaging host application. And then it can sort of process that information and then send it down a separate named pipe where the browser can get the output and then work in the extension with that. I should note before we move on that although there is an exe logo for the native messaging host application, this can be anything that supports standard input and output, so scripts. So you could have Python, Batch, PowerShell, anything would work, as I say, as long as it handles standard input and output. And the system obviously knows how to run it. So that kind of brings up the question, how does the browser know what to talk to and how to talk to it? And that's kind of broken down into sort of two parts with 4 things, right? So we've got the stuff that's part of the extension when we install it into the browser. So that's the extension manifest and the sort of JavaScript behavior. And then also, that's kind of half the story, right? We need a native messaging host manifest and native messaging host registry key. But these are not part of the extension when it's installed through, say, the Chrome Web Store, right? These need to be separately added. So you can do that manually, or you can do that through an installer or a script. Now we'll go through what each of these 4 things are in the next few slides. So the extension manifest, as I say, this is part of every extension when it's installed. It's basically just a description of what the extension can do, what features it requires, and some other miscellaneous bits. This is sort of a slimmed down example. So we've got stuff like the name of the extension. We've got sort of descriptions. They're all pretty self-explanatory versions. Then we've also got a key field. So when we compile sort of the raw files of an extension into something we'd want to upload to like the Chrome Web Store or whatever browser web store, this key field would be added at the compilation stage. And it's essentially an integrity checking feature. So it basically sort of encompasses all the files of the extension. So if any of them are modified, this key would be invalid, and the browser will know sort of the extension has been tampered with, and it's not going to load, right? So that's kind of nice from a security point of view. Then got the background service worker things. That just says what JavaScript files are going to have the sort of main behavior of the extension. And then finally, we've got the permissions, which every sort of extension will have some sort of list of permissions that it requires to do its job, some more than others. And you'll notice that I've put native messaging there. Native messaging is required to be explicitly defined as a permission for us to be able to sort of leverage that functionality. If it is not there and we try to call the functionality, it just isn't going to work, right? And if you remember as well, I said about the integrity check and key. Well, because that's there, we can't just sort of add it in after the fact. It has to be part of the extension when it's sort of installed. The next bit was the JavaScript sort of behavior. Now, this is quite simple. Just to start up the application, sort of the native messaging host application, is one line, really. So that's chrome.runtime.connectNative. And then we'd pass in the extension name, which is defined in the separate manifest, which we'll go through in the next slide. I should note before we move on that we can use chrome.runtime.connectNative, but browser.runtime.connectNative also works as well, the exact same. And that'll be useful, you'll realize, in sort of a couple slides' time. And also, if we want this to launch the native messaging host application when the browser is sort of started up with the extension loaded, we can add this listener, so chrome.runtime.onstartup.addListener, and wrap that function around this. And when you open the browser with the extension enabled, it will just kick off the execution of the native messaging host application. And again, Chrome can be replaced with browser here. So now we're going to move on to the stuff that's not part of the extension when it's installed from, say, the web store, right? And the native messaging manifest is one of those things. As I said in the last slide, the extension name for the native messaging host application is defined here, and it's usually in the structure of com.companyname.extensionname. Then we've got a description, which is a description. We've got the path to the native messaging host application itself. So here, it's just calc as sort of an example, but yeah, you could have your script or whatever executable you want. Got the type of communication, so stdio is standard input and output, and then we've got the allowed origins, so which extensions are allowed to talk to this native messaging application. And then the other thing that's not included when you install the extension from the browser application store is the native messaging host registry key. Now, this can be stored in either HKCU, or the current user registry hive on Windows, or HKLM, which is the local machine sort of registry hive. Obviously, if it's in the current users, then it's only going to sort of take precedent over the current user. And for the local machine, if any user on the system has the extension installed, this can be used for all of them, which is kind of nice. Now, for Chrome and Edge, I apologize if that's a bit small, it's in the location in both HKCU and HKLM of software, Google Chrome, or Microsoft Edge for Edge, a native messaging hosts, and then the extension name, which we defined in the previous slide in that other manifest. Then the value we have in that key is just of a default name, so you just leave that blank and it will set it to default. And then the actual value itself is just a path to the manifest in the previous slide, that native messaging manifest, right? So in this example, it's just C ProgramData native.json. So after sort of looking at all of this and looking at what native messaging is, continued to reverse engineer and look at the executable that we saw in that sort of client example and look at the rest of the extension. I actually came to the conclusion that after looking at all of the functionality, the extension that the client was worried about wasn't actually malicious, right? It was just native messaging making this look really dodgy. Now that made me think, well, if this looks really dodgy, I bet you there's some really dodgy things we can do with it, right? So that immediately made me think, well, this seems perfect for persistence, right? Seems like a great way to persist. It can start an arbitrary script or executable when the browser is opened, and most users, if they're on a workstation, at some point in their session are going to open the browser, so that sort of trigger is sort of almost guaranteed to happen. And even on servers, a lot of servers have some sort of browser installed for sysadmins, right? Maybe it's not used as much, but yeah. And that kind of sort of brought up another question. Well, has anyone already done research into this? Does this already exist, right? So when I found this sort of technique, I wrote up an internal blog post in WhiskerSpy, so I could share it with my colleagues if they wanted to use this technique on any of their red teams or other jobs. And as part of that, I sort of searched the internet to see if anyone had looked at native messaging or anything sort of adjacent, right? And I saw nothing, which made me very happy. Thought I found something new, great. So I posted the internal blog post, and a colleague a few minutes later pointed out that this exists. This is WhiskerSpy, and all credit to Joseph Chen and Jaromir Horjsi, apologies if I've mispronounced that, of Trend Micro. Great blog post. I won't go through the whole thing, but summarized one bit that's relevant here. One version of WhiskerSpy used an MSI file, an installer, to install the required manifests and registry keys. It then did C2 via the native messaging, which is kind of cool because sort of from a process telemetry point of view, it's kind of less obviously bad because instead of the implant talking directly to a C2 endpoint on the internet, it passes that traffic over native messaging through the browser, which obviously is much more likely to talk to random things on the internet rather than some random binary or script, right? So that's a lot less sort of suspicious. And then it runs on startup like we suggested with that red JavaScript code earlier on. So that kind of took the wind out of my sails a little bit. I was like, maybe this isn't as new as I thought. But then it got me thinking, well, the stuff we'd found was an actual threat actor abusing it, right? It wasn't like a research paper of someone sort of doing a deep dive into the functionality and seeing what could be done. And they were doing some very specific things. So it just made me think, well, there's still a lot of possibilities here. There's a lot of new things we could try and find. So I tried to sort of ask myself a few questions for further research that I wanted to answer. The first was, does anything else use native messaging? The second was, what other ways could we deliver this? And the third was, does this functionality expose any other attack surface? So on that first question, does anything else use native messaging? The short answer is yes. Most browsers have support for it, Chrome, Edge, Firefox, and then all Chromium browsers, unless it's sort of been specifically removed, they'll have sort of support for this. And it also works on all major OSs, so Windows, Linux, and macOS. Obviously, sort of implementation between browser and OS, all the different ones, is going to be slightly different, but it's pretty much standardized and pretty much the same. The main differences are like, well, the registry doesn't exist on Linux and Mac, so it uses files instead, and that sort of thing. But from sort of a cross-platform exploitation point of view, this is really nice, as most things we're going to land on like a red team, or as an example, are going to either be Windows, Linux, and Mac. It's not many other options there. And they're probably going to have a browser installed, and probably one of the popular ones like these. So it's kind of nice. So the second question was, what other ways could we deliver this? Now, our research was sort of very manual. We were putting files in place and registry keys in place by hand because we weren't trying to exploit this. We were just trying to see what native messaging was and understand a bit about that. But obviously, again, if we're going to do this on like a red team, that's not the most practical thing. And then WhiskerSpy used an installer, which is, well, it worked here, but in sort of my experience, I've seen some environments just block MSI files altogether because standard users shouldn't be installing stuff themselves. And if it's not blocked, it can also cause alerts in some environments as well, which again, isn't the best if you want to do this on like a red team. So what options did I come up with? Well, I kind of came up with 3 different ways we could do this. And the first 2 sort of involve trying to load a vulnerable extension on that we can exploit if there's not already something vulnerable on there. And the third one is sort of exploiting what we've already got. So the first one is forcing a download of an extension through the registry. The second is backdooring an existing shortcut file. And the final one is enumerating installed extensions. So on the forcing the download through the registry, you can do this for both the current user or all users on the machine. No user interaction is required, and if you've got any group policies in place that stop extension loading, this gets around that. And as I put here, it can be used to run code as another user. So as sort of an example, if we force install this extension to everyone on the machine and then put the required native messaging files in place, well, we could run code as any of those users whenever they open the browser next, which is kind of nice. The locations for Chrome and Edge can be seen on screen. Again, this is both HKCU and HKLM. I should also note that Chrome can only download extensions from the Chrome Web Store, but Edge can download both from the Chrome and Edge app stores, which is nice. And when we sort of look at the registry key, I'll explain sort of the nuances for that. The downsides to this technique are it requires admin privileges for both HKCU and HKLM. So even if you want to force install for your own user, you're going to need admin for that. And it only works on Chromium-based browsers, hence why I only sort of listed Chrome and Edge. As an example of what this key looks like, again, it's in that location for Chrome that I mentioned. The value has a sort of an incremental number as a name. So we've only got 1 here, so it's called 1. But obviously, if you had another, it'd be called 2 and 3 and so on. And then the actual value data is the extension ID, which we can get if we install the extension on, say, a lab machine and look at our installed extensions and look at the URL. We can get it from there. Semicolon, and then an updater URL. The one on screen is the one for Chrome. Edge has a separate one, but as I say, this is the Chrome registry key. We can use that exact value in the Edge one because it can install from both Edge and Chrome, which is nice. I haven't put the Edge URL on screen, but it's in the tool, which we'll get onto later on. The second method was backdooring existing shortcut files. So most people use shortcut files to access their common applications, right? Whether that be on the desktop, in the taskbar, or the start menu. These are all LNK files at the end of the day. The taskbar and start menu sort of locations for users' LNK files are on screen. The reason this is nice is because Chromium browsers have a command line to load unpacked extensions. And what do I mean by unpacked extensions? Well, those raw files, the JavaScript, the images, the manifests, everything like that that gets sort of compiled in the end. Before it gets compiled, those raw files would be sort of the unpacked extension, right? And what we can do is we can use the --load-extension argument to load those files from a folder directly into the browser. So when the browser process is started with that sort of argument, it'll automatically have the extension that we want installed, no sort of pop-ups or anything. It's installed and enabled, which is very nice. Now, what we can do if we know where the user is, which LNK files though the user is using, we can backdoor those. So we can just add to the end of the target command line for the LNK, the --load-extension, and then when they next click their shortcut file, it will load with our sort of malicious extension forcefully sort of installed and enabled, which is nice. It's kind of stealthy, this technique, because, well, I don't know about you guys, but every time I open an LNK file, I'm not right-clicking, going to properties, scanning to the end of a very long sort of target command line every single time, right? So from a user point of view, they're probably not going to notice this. And especially if you're doing it for like the taskbar and the start menu, most people don't realize that those are LNKs, let alone where they are, then to go and do the properties, scan to the end of a long target command line, etc., right? So pretty stealthy. I will say on Edge, unlike Chrome where there's nothing, there will be a warning about extensions that pops up, but it doesn't actually stop anything. It's pretty small, so this is what it looks like. It doesn't say anything like, oh, this has been tampered with or anything like that. It's just sort of a generic, you can turn off extensions in the desktop mode. So it's not sort of obviously, you've been tampered with. And if you click anywhere on the screen, it'll disappear. So I personally think most users are probably going to ignore that. If they see that, they're not going to think too much. The downsides to this technique is if you do have any group policies in place that stop extension loading for users, this will actually stop that, which is nice, and only works on Chromium-based browsers. And then finally, the most exciting technique, in my opinion, is enumerating already installed extensions and sort of hijacking them. So if stuff already exists with the native messaging permissions granted, well, why not sort of take advantage of that, right? We can write the manifest ourselves if they don't exist. But yeah, if they already do exist, we can overwrite them if we have those permissions, which again is nice. The main thing you'll need for this is an extension name. So from the manifest we talked about earlier, the native messaging manifest. So you could either get that through installing the native messaging features and the extension in like a lab environment and sort of looking where that native messaging manifest is and just taking it from there. Or if you just want to do it all on the same host, look at the extensions files themselves and find in the JavaScript where connect native, that connect native method is used, and just look at what's passed to that and you'll have that extension ID. Because obviously it's required to start up the executable or script. This is the stealthiest and cleanest method because, well, you're literally jumping into the legitimate flow, so this looks legitimate. The main sort of downside is not every extension supports native messaging. As I say, it has to have sort of the native messaging permission explicitly set. However, in my experience, a lot of the time, native messaging is kind of like an optional feature. So a lot of extensions have support for it, but it's not required to have it configured for just the extension to work. So a lot of the time, I've seen it sort of in there and in sort of client environments where it's just not being configured because the sysadmins probably don't even realize it's got native messaging capabilities, right? So it's always worth a check to see if stuff already has it. And obviously, if all the extensions installed on the machine do not have native messaging permissions, we could use one of the other methods to try and install an extension which did, right? And this can actually set us up for some further offensive steps, which we'll get onto in the next slide. So the final question I wanted to ask myself was, does this sort of functionality expose any other attack surface? And again, the short answer is yes, it does. There are multiple points of failure, and there's no sort of standard or documentation saying the right way to do this, which usually means misconfigurations, right? We have the following files as sort of a raw attack surface that we can target. We've got the native messaging manifest, we've got the native messaging host application itself, and we've got the native messaging registry key or file on Linux and Mac. If any of these do not exist, or we have permissions to write over them, we can hijack, right? This is especially impactful if we know other users on the same machine have the extension installed. And we'll get into an example of how we could use this for privilege escalation in the next slide. But quickly, before we do that, I just want to sort of point out that we won't go into it loads in this presentation because it's a bit out of scope, but you could also look for vulnerabilities in the native messaging host application itself. And if you were able to find one, it would essentially act as a cheap browser exploit. And what I mean by that is a lot of these extensions would sort of look at every page you visit to sort of see if they need to do anything and send that data, some of the data on the page back to the native messaging host application to, again, see if it needs to do anything. Now, if we could put some sort of malformed data on the web page and it got sent back and it caused some sort of maybe binary exploit or whatever, and we got code execution, that would be obviously code execution, which is nice. Unlike sort of traditional browser exploits where you'd need to sort of do sandbox escaping or other things to actually make that code execution useful, because this is running in a separate process and it's not sort of hold to the sort of security features of the browser, we just have straight up code execution straight away. So that's kind of nice. Anyway, the example I wanted to show was if you had the native messaging manifest in C ProgramData, we can probably overwrite that, right? Because by default, it's readable and writable by everyone on a Windows machine. If it's a corporate extension, other users will probably have that installed, and the browser will likely be pointed to the same manifest, which would equal for us code execution as other users, because we could rewrite that manifest to point at an executable or script of our choice and run that, which would be nice. And that's also from potentially low privileges, because again, program data is readable and writable by everyone on the system by default. The same goes for if the native messaging registry key is misconfigured and writable, or if the native messaging host application or its DLLs are misconfigured and writable. So also DLL hijacking and that sort of thing would also work here. I will say that this is a scenario I have seen like in real life before. Again, I think this is a symptom of that it's not sort of a documented way to implement this. So sysadmins it's not their job to think about security, it's their job to sort of get things working. So they might do this, and it's sort of an easy thing we can jump on and exploit on the red side. So we've talked a lot about the offensive sort of side of this. Let's go to sort of more the blue team sort of side. So are the blue team already aware of this technique? And the answer is kind of no, not really, which would make sense because, well, when I searched for anything to do with native messaging research or anything like that, there was nothing. And then there was that one blog post from one specific threat actor using part of this technique, right? So it's not like a widespread thing, so it makes sense that it wouldn't be sort of widely known. I did, however, find this blog post by Enviso Labs from 2018, which kind of covered some adjacent things. It basically goes over detecting weird child processes, and in particular, the stuff I wanted to draw attention to was this. So this is part of their blog, and if I highlight this command line here, you'll probably recognize that from the very beginning as being very similar to the command line we saw when we looked at native messaging. They also say, this immediately caught their attention, why is Chrome spawning a command shell? That's pretty dodgy. But then they go on to say that it's actually not a sign of malicious activity, but not a false positive for the rule they were creating because they were sort of looking at suspicious child processes, right? So, if they had this rule implemented in 2018 and we were trying this technique and hadn't made it public, right? If this caused a sort of an investigation, they could have potentially identified us doing sort of malicious things without this all being a public technique, right? So it's a very nice rule because, again, it caught stuff that didn't even exist at the time this was written. So very nice. I really recommend you read this blog post and implement those things in your environments. But yeah, all credit to this goes to Dan Rahman of Enviso Labs. Very good blog post again. So how can you protect yourself from these techniques? There's a couple of mitigations you can do. So you can add group policy or registry keys to stop extension loading. That will cut out a bunch of those delivery techniques that we mentioned. For Edge and Chrome, those are the URLs to get the group policy templates. And then also, we can ensure native messaging applications, their manifests and registry keys are correctly permissioned, which would stop the privilege escalation stuff we talked about. And then for the stuff we can't mitigate entirely, we can also put detections in place and detections in place to catch if we've got threat actors trying the stuff we've mitigated. So we can create alerts for if a registry key is created under the native messaging for a browser. We can create alerts for if the extension install force list registry key is used, because someone's probably forcefully trying to install extensions. We can also create alerts for if --load -extension is used in a command line. Now, typically, I don't like recommending command line-based detections because, we've had some other talks in this event that talk about how you could sort of obfuscate this and make this sort of break those detections. However, the tool that I wrote, that I'll get onto in a minute, uses this specifically. So if someone's using the tool we wrote, then yeah, that would catch this. Or if someone's not being OPSEC safe, this isn't likely to be seen legitimately in an environment. Maybe if you've got an extension development team, you might see this, but it should probably be investigated because, again, it's not going to be likely, and if it is there, it might be someone trying some of those delivery techniques that we mentioned. And then the final thing is creating alerts as Enviso described in their blog for uncommon child processes, because again, this caught our technique, well, could have potentially caught our technique if it was investigated before it even existed. So it could probably also catch other things as well that maybe don't exist yet. So yeah. And then the final thing I want to talk about is there an easy way that you guys can test for this? And yes, it might sound like a lot to do for yourself. So we've made a tool to sort of automate this and make testing easier. It's only on Windows at the moment, and it has 5 main bits of functionality. So we've got reconnaissance, which will look at all the extensions it can see installed on the machine. Obviously, if you're as your current user, it will only see that. It will then look if they've got the native messaging permission allowed, and then if they do, it will look at all of the native messaging registry key and file locations to see what their permissions are and can we hijack them. Installation uses the registry key force install method that we talked about in the delivery section. And then we've got the LNK path recovery and LNK backdooring, which are kind of related. You can pass an LNK file to the path recovery part, and that will just tell you what the target path of the LNK is. And then the backdooring adds the --load extension, and then the folder that we want with the unpacked extension in. And then finally, persistence is the bit that weaponizes all of this. This will put the registry keys and manifests in the correct place to make this work and execute when we open a browser. The repo also contains some example vulnerable extensions, so you can look through some code for that. And all of the documentation and source code can be found at that URL. I'll just go through a quick demo, and then we'll wrap up. Oh, there we go. Cool. So here's me opening a browser and just looking at the installed extensions. So we can see we just got the default Google Docs offline stuff. That's part of Chrome. So what I'm going to do is open up our tool and use the install feature, which will use the registry key force install. And all we'll need for that is the extension ID, which I mentioned we can get if we install the extension in like a lab environment and then look at our installed extensions in the URL. So I'll open the browser 1 or 2 times to sort of speed up the install. But when I open it this time, I'll go down to the extensions. And then if we wait 1 or 2 seconds, we shall see 1Password was sort of installed without any user interaction, which is nice. This is obviously the example from the MViso Labs blog post, because that has native messaging. So the next thing we'll do is we'll run the recon command, which will look to see if anything on the system has the native messaging sort of features. So you'll notice there's a lot of output because it scans Firefox, Edge, and Chrome. So if we scroll to the top, we shall see that, here we go. There's the 1Password extension from the ID that we put in, and it points out that it's potentially vulnerable. And then it says about if there isn't a manifest or registry key, well, we can create that right and sort of hijack this. So it mentions, as we talked about before, we can get the extension name from the connect native method or by installing it on sort of a lab machine and taking it from the native messaging manifest. So once we've got that extension name, what we can do is we can use the persist functionality with the extension ID, the extension name, and a path to the executable or script that we want to run when the browser opens. So here you can see I've just run that. It's successfully persisted. Nice. So when I next pop open the browser, if you watch the sort of taskbar, you shall see calc pops up, which is nice. There we go. Code execution when we open the browser. Then finally, what I'll do is I'll run the recon command again so you can see what hijackable files and registry keys look like, because obviously we just wrote them, so we're going to be able to overwrite them. So again, I'll run the recon command, scroll back up, and you'll see the com.1password.1password. We can see it says the key is writable and hijackable by the current user, again, obviously, because we just wrote it. And the native messaging manifest is writable and hijackable by the current user. There we go, at that path. Obviously, calc isn't overwritable because, well, that's a system file. We can't do that. But yeah, so that's what it would look like if you have a misconfiguration in your environment, which is kind of nice. I think I just opened the browser 1 or 2 times to show calc popping again. But yeah. Cool. So as a summary of what we've gone through today, turns out the extension I was looking at for the client wasn't actually malicious at all. However, it kind of prompted the research that native messaging can be used for persistence and privilege escalation. We can persist using the registry, backdooring shortcuts, or exploiting existing extensions. And you can also exploit this technique to execute code as another user if we either have permissions to write over the backend files and registry keys and the manifests, or if we exploit the native messaging binary itself. From a blue point of view, you can prevent some exploitation via lockdowns of file permissions and GPOs, and the stuff that you can't lock down, you can alert on as anomalous telemetry, which this technique produces. And you can also download our tool for a proof of concept. That's all from me. Thank you all for listening. If you've got any questions.
What kind of noise would we see if we set up detections like this, if we manual detections on our EDR tool? Would it be a lot of noise, or like for the native messaging app?
So for the stuff I went through, I tried to kind of pick stuff that wouldn't sort of have a lot of noise that you probably wouldn't see very often in an environment anyway. So like the extension install force list, well, only admins should have admin, so it should only be them. And I wouldn't have thought many times you'd have people needing to install extensions for everyone. So if you see this, you're probably worth checking sort of, is it an admin doing it legitimately, or is it sort of a threat actor who's abusing this? Then, as I say, the load extension stuff, again, there's other ways you can do this. And if you're an extension developer, you'd probably do it the other ways. So yeah, you just wouldn't likely see that in an environment. And then the registry key being created under native messaging for a browser, you'd only sort of do that when you're configuring native messaging for an extension. And again, if you're not installing an extension like multiple times an hour or something and having to configure it every time, you wouldn't be configuring this key all the time. So those things should be pretty quiet. Again, it'll be environment specific, but yeah.
And one follow-up, if you don't mind. Would 1Password be a good one to test with? I wanted to set up my alerts and then see if it was going to hit.
Yeah. So the question for the recording was, would 1Password be a good example? Yeah, 1Password, when it sort of launches, it'll automatically try and start whatever it thinks is 1Password, which is fine, normal functionality if you've got something configured and properly permissioned, but we can hijack that. Or, as I say, we've got example extensions in the repository which are vulnerable as well, so you could use those. Yeah.
Can you just go back to the LNK explanation? I think I missed what exactly you were referencing. Were those LNKs on the host?
So those LNKs, if I can get back to it, yeah. So the LNKs I was talking about were for, like, on your desktop, obviously, if you've got a browser link, or in the taskbar. So on, I don't know who'll show on there, no. If I had the taskbar up, all of those are LNKs in that location just there. And then in the start menu, if you try and launch something from the start menu, all of those are also LNKs in that location just there. Yes, the question was, do we have a link to download the tool? There. The question was, does anything stop this from sort of a watering hole or social engineering attack? Obviously, we'd need to install the registry key and manifest files, so you wouldn't only have to sort of socially engineer someone to install the extension. You'd need to either get them to run a script or an MSI or put those files in place. And then also, in terms of installing extensions, the browsers that I've looked at, they kind of check the origin of where you're trying to install that extension from. So if you think when you go to the Chrome web store or whatever, you press install extension, it just installs it into your browser. Well, if you did it in somewhere else, you'd just get a CRX file downloaded into your downloads folder because it's not come from that sort of origin. So, yeah. Yeah, so the question is, for enumeration, you'd want to check for native messaging in the manifest. Yes, this tool does that in the reconnaissance part. So, as I say, it'll check all the installed extensions that it can see. It'll look through the manifest to see if native messaging is there. If it is, it'll say it's potentially vulnerable. And then, as I say, also, if you have any native messaging registry keys or manifests installed, it'll also check the permissions on those to see if your current user can overwrite them. And if it can, it'll say these are hijackable. Yeah, so if they don't exist as well, when you see it sort of says potentially vulnerable, if you then don't see any files for that extension in registry keys or manifests, you can sort of just, as I say, get the extension name from either the connect native method or by installing it in another browser and getting it from the native messaging manifest, and then sort of put them in yourself using the persist functionality. And the persist functionality just does it all for you. There are more options for the persistent stuff in the tool, but I just sort of did the least that are required for this demonstration, so you can configure it how you want. Yeah, so the question was, there any sort of recommendations for Enterprise Chrome and Edge? As I'd say, you'd be best doing the group policy stuff that I mentioned here. So you put the group policy templates in place, which would stop extension loading, and that would take out a few of the delivery methods. And then also checking to see if the permissions on any native messaging you do have sort of put in place. So the manifest and the registry keys, just make sure not everyone can write them, because that's an easy way to stop PrivEsc. And then as well, as I say, the detection stuff is also useful, because the mitigations will only stop so much. These are just catching everything else. Any other questions?
Yeah, from the virtual. They asked, how can this be used across an enterprise environment? Could you deploy via service account?
Yeah, I mean, if you could put the registry keys in and then put the files in place, sort of, for example, if you did the force install stuff, I guess you could sort of put the registry keys in place to, if you had admin, install for all the users, and then you put the native messaging host manifest and registry keys in place. It would launch whenever they open the browser if you had a malicious extension. That's everything. Thank you.